Yeah, okay. Thank you, everyone, for attending the first of our free online events here today. This event will be recorded, and recording will be made available later. Feel free to ask on chat if you don't want your voice to be included, but also, yeah, feel free to ask via voice anytime. I will start sharing the presentation. I think it's interfering with what we have already, Daniel. Do we need to close the other one?
Shouldn't be a problem, because if simply you share your screen.
Oh, yeah, no, it's fine. Okay, so. All right. If anyone cannot see my screen right now, please complain quickly. So the motto for talk today is Agile Research Data Management with LinkAhead. As I said, this is a part of a three-part series. The next events you can find at IndiScale.com/events. I will go a bit into the history of us as a company and the software that we're using. So LinkAhead started the Max Planck Institute for Dynamics and Self-Organization in Göttingen, Germany around 2011. And the project was started under the name CaosDB, which exists as a version of the software to this day. It's been running stable since around about 2016 and has been released as open source via an AGPL license in 2018. In 2019, IndiScale as a company was founded, and we've been seeing increasing adoption since 2020 when other institutes started using the software. So the software, when it was started at Institute, was mostly used by my colleagues for their PhDs. Afterwards, when other institutes started using it, we started a company to provide commercial support, as I said, as IndiScale GmbH, and the version that we distribute is called LinkAhead. But as I said, CaosDB still exists to this day and is maintained with the same code. Down here you find the GitLab link to CaosDB, and these are the logos of the different distributions and our company. So, as many of you have seen probably already, here is another data lifecycle that we will use to showcase where we see LinkAhead plugging into your research cycle. And as you can see here, we have you start your research usually with some kind of idea, with some kind of question that results in some kind of lab data, continues to be processed into some experimental results. Then you probably do some more simulations, you do some processing, some analysis on it, and ideally at the end there is a publication that results in more research. This process starts all over again. And very often when you have when you start in such a cycle, you ask yourself questions like, where is my data, or where is data from someone else that I want to use? How is the data that I'm trying to do further research on connected with other data? Where's the metadata going with this data? And what do I do if data structure changes, has been changed, or will be changing in the process? And confronted with these problems, that's how LinkAhead came into existence, because LinkAhead is a tool that works with when you already have data as a result from your scientific praxis or research. So LinkAhead tries to track whatever happens in the different parts of the life cycle, how data relates to its metadata, what versions of different data exists, who is accessing them, what is the access controlled, so that you can keep track of what has been happening and have like a good paper trail of what has been happening with your research data. You're probably aware with the challenges that we have in research data management. For one, we have findability. So just keeping track and finding data that has been used, that you already have somewhere in some kind of system, in some kind of format. Then the linkage between the data, so keeping data together with its metadata, and at the same time, we are working in a dynamic environment in research where unexpected things can happen, where experiments change, or where you have results that make you want to adapt to your data model. And this is where LinkAhead is offered to you as a tool, for one, to link data files with their respective metadata, keep the data embedded into its original context, and yet in the end have very powerful semantic search through LinkAhead for your data, where you can do very precise searches for experiments or other data. We will show a bit more of that in the demonstration in a few minutes. And at the same time, since LinkAhead is a tool for active research, we want to be able to keep adjusting the data model while doing research. And we want to be so close to it that you can actually change the data model while making an experiment, that you can add a new field, add some new results without breaking your whole data model, or without needing anyone else, if it's not set up in that way, to change the data model for you, which could take some time depending on your IT, on how your IT infrastructure is set up. So then we have a bit of an overview. What other software we've been seeing, what we've been considering, and what problems we see with them when we were thinking, how do we create LinkAhead? For one, there's like the classic data lake, which we consider too swampy as a good research management tool. Then there's SQL, which for research data management we find too rigid to deal with. And then there's also GraphDB, which we consider too complex for the average researcher to use as a tool. That's why we created LinkAhead, where we want to have like the good parts while having easy to use interface and tools for the system with it. So automation is also a very core value to why we created LinkAhead, because in our opinion, there's a lot of parts of the research process, especially when working with machines, especially when working with experiments or external data sources, where a lot can be automated, which will free up time for research and will save you the risk of errors while humans perform some kind of repetitive work. Also, since we see that a lot of users do the same searches all the time, because new data comes in, you can also store the search templates in your LinkAhead instance and easily do the same complex search queries and look at the results. And this is all a very individual process. Usually people come with all kinds of different machines, data sources, data infrastructures, and we as IndiScale are happy to help you automate the work for your instance. Feel free to reach out to us anytime to discuss any work that might be needed in that regard. So here's a bit of a technical overview that I will go through very briefly, but if anyone has any questions about them, feel free to ask. So we have a classic client-server infrastructure, client-server setup. And for one, we have the web interface, which is for the average user that still offers a lot of functionality to it. We also have two APIs. For one, the REST API that is used by the CaosDB crawler that I will go into in a minute. For Python advanced tools and PyChaosDB. And then we have the gRPC API that already has some libraries. So we already have C++, JavaScript, Julia, and Octave libraries. And an R library is already work in progress. CaosDB has an SQL backend that is based on MariaDB and MySQL, and it sources data usually always from a file system in the local network, and we're also working on using object stores and the cloud also as a source of files to feed into the system. As I said, this is a work in progress, but it's not out too far. Then a very important part of LinkAhead is the crawler, because we want to allow users to keep their existing workflow. We don't want LinkAhead to be a tool that changes the way people do their research in a way where they have to get used to different tools, different systems, but just as an adaptive tool that offers more functionality while people can use their same routine. So, for example, that means, if people work in some kind of tables or any kind of other files, they can keep doing that, and the crawlers will be optimized to get and keep track the data from these different places. And there's different plugins as well. And Daniel, I will hand over to you in a minute. We have this crawler. It keeps track of files by giving them an identifiable, which will allow it to keep track of the different instances. Daniel, you want to take over?
Yes, sure. Okay, thank you for this for the first part, Thomas.
Do you want to say something more for the crawler, or?
Okay, yes. If you want, I can talk a bit about the crawler. Crawler actually is a framework written in Python, as Thomas said, to go over existing bits of data, which typically are files on a file system, but which could also be rows in Excel sheet, which could be rows in some existing SQL database. And this crawler handles these bits it gets to plugins, which can be customized, and then these plugins decide whether these bits of information should be entered as new data into LinkAhead, whether existing entries in LinkAhead should be updated according to changed bits of information, or whether everything is fine already. Yes, I think it makes sense now to switch to a small live demo.
Yes, does anyone have any questions so far? Please feel free to ask at any time. I'm not sure I said that yet. If not, we'll stop sharing now and give the screen over to Daniel.
Yes, thank you. Okay, so this live demo actually is something which you can do yourselves, because I hope you can see it now. Because it's the live instance which you can find at demo.indiscale.com. If you go to demo.indiscale.com, you see okay. And it's here that there's also there are login credentials, admin with password CaosDB, which I do now, admin here, CaosDB here, then I can log in. And then as an example, actually in this demo we have several example scenarios, and one which I will look at now is about a lab setting. And in this lab, we have standard operating procedures. Now, if I want to find them, I simply say I can find SOP. And find SOP gives me all the entities which are stored, which are standard operating procedures. And as we see here, there are two types of entries. One are these with the green RT, and then there are those with the red R. The red R stands for record, and the records are actual pieces of data which are stored, whereas record types are, as the name says, types of records. So typically you create some record types for the data you think you will need to store, and then later on you create records which are based upon these record types. So for example, this record here, which is a biopolymer preparation procedure, and it's here, okay, this has another rectangle here, which means that it is of the type simple procedure. Now the simple procedure here is the record type. It has some properties like preparation temperature. Okay, thank you. Yes, which has a preparation temperature, which has an analysis frequency, and so on. And then then you see that this record type also has a type which is SOP here, which has properties like author and procedure, and this means that the simple procedure record type inherits from this more general record type, and in a certain way, is a child of this and inherits all the properties. Of course, as you see, this record here has both. It has an author and a procedure, which it has inherited from this SOP record type, but also has more specialized properties like preparation temperature here. There was one question in the chat, whether it's possible to just click enter here. Unfortunately, in the moment not. You have to click on this or press enter on this magnifying glass here. Okay, let's go further. For example, what you see here in the properties is that, of course, you can store all kinds of properties like text. You can store numbers, which can have a unit, Kelvin in this case, so the temperature is 320 Kelvin. But of course, you can also store references to other entries. So for example, the author here is a reference to the entity 332, and if you click on the preview here, you see, okay, this is some person, the author of this procedure, and this person, of course, also can have other properties or can have references to more things, and this to more records, and this is a reference to another person in this case. Now, if you can find out where a record links to, for example, I can click here, of course, then I get to this entry here, but I can also find out which other records link back or link to this entity, and for this I can use this references button, which tells me, okay, which references are there which link to this SOP record, and there are two in case, there are two records actually, and each of these, of course, has more references to other records. So basically what we have here is a complete graph of interconnected entities with which you can store all the data you need in your research. Yes. Now, of course, it may be fun to simply click on all of these entities, but if you do serious work, you want to find, you want to filter, you want to find some special entities which have some special properties, or maybe linked to other entities which have some properties, and that's exactly what you can do. So, for example, instead of this very simple find SOP, what you also can do is you can try to find a study. So we want to have a study, and the study needs to have certain properties. For example, we want to have a study with samples, or we want to have a study which has a reference to a sample. But the sample should also have some special properties, because there shall be some analysis. In this case, a tensile analysis is how we call it, and this tensile analysis also shall have a certain property, tensile strength, and a certain property as tensile strength shall have a value of, for example, more than 100, more than 140, and I can even get a unit, so I can say, okay, I want to have tensile strength which is more than 140 Pascal. Now, if I look for this, I get exactly one study, and the study, of course, has some samples here, and one of them, I think it's a hard sample, has a tensile analysis, and this tensile analysis has a tensile strength. Oh, that was the record type. I want to click on this here, and this has a tensile strength of quite a lot, of 1.46 to the 7 Pascal, which is quite a bit larger than those 140 Pascals I asked for. If, on the other hand, I said, okay, I want to have something with smaller than 100 Pascal, maybe that I get it or not. In this case, well, there are no results because I didn't have any sample which was so soft. Now, this is all nice to get an overview in the web interface, but of course, as you know, if you want to do really serious research, you don't want to click on everything by hand. You may want to get this. You may want to analyze the results in some other programs, and for this, I can simply replace the find by select, and then I can do, for example, preparation.
Daniel, there's a question in the chat. The search did not lead to the result. You know what the result was?
The search did not lead to the result. You to know where the result. Oh no! Oh no! If I have a query like this, which doesn't have any results, this means that there are no data sets in this database which fulfill this condition.
So it was intentional. We knew that. Yeah. Okay.
Okay. So for the next example, I want to have something like a table, and for this I want to have, for example, the temperature of some preparation and the tensile analysis records for this. Yes, and I want to have them for all the records of type sample which exist. And in this case, I get a small table, which because our database is so small here, we only have 2 examples. We only have 2 sample examples, so to say. For these, I have to have here a table with the temperatures and with the tensile analysis records linked here. But of course, I may want to analyze this further later on. And for this, I can say, okay, I want to export this. I can download it either as a table file, or which is something which I like best is I can also simply take this small code snippet and then copy and paste this and then use this in a Python script, for example, which is then able to do some automated analysis on which is then able to do some automated analysis on the result which is returned by this very small, concise query. So for me, this means that we always want to make it easy to switch from the web interface where it's easy to look at the data by hand and see which kind of data we have. We have a lot of entries which fulfill some criteria and so on. But then I want to make it easy to reuse So if I really want to use it in practice, I want to make it as easy as possible to really reuse the queries I create here, and then use them in some scripts for automated research later on. Okay, are there any questions so far? I see 2 people typing. How are the data stored? Is this a single file? Well, as Thomas showed in the presentation, LinkAhead uses a plain SQL database as the backend, and the data is stored in this SQL database. In the end, this is at least this is true for all the data you can search for. For binary files, for example, if you have data files and you want to store them, these data files are only stored as references within LinkAhead. Does this answer the question?
Sorry, not fully.
Okay.
I'm totally out, I have to admit. Sorry. If I have data from any data acquisition system and I have those, regardless if it's ASCII or a binary, how do I bring it into the system?
Okay. Well, so if I understand you correctly, your data is typically stored as a file by your data acquisition system, and you want to have this data file inside LinkAhead. Is this how you?
Yeah, that's the first step. So that is,
Okay.
I missed. Yeah.
Okay. So we have if you want to store files in LinkAhead, it's simply you can simply upload them as files. But what you typically would do is you would give LinkAhead only a link to the file on some network file system or so, and then store the metadata in LinkAhead and have a reference to the file. We have a few files here. Let's say file. We can go to the file system and look at some files. So now we have some analysis files. So for example, we have one. So for this example, we have a kind of musical analysis of a musical instrument, which is simply our example here. And this analysis record has a reference to a file entry. So for example, we have a setting CSV, which we have here. We have some time series here, and so if you want to store this, if you want to store your file inside LinkAhead, you typically want to ask yourself, what is the context in which I want to store this file? And typically a file doesn't exist on its own, but it's part of an analysis, it's part of an experiment, it's part of some numerical simulations you do. So you basically would then, if this was a file from an experiment, you would say, okay, I create a record for the experiment on this day, and then I create a kind of an attachment to this experiment, and then I store the file in this attachment, because this file typically belongs to some broader context or so. So for example, so in this example, we have this analysis record, which is a musical analysis of an instrument, and then we say, okay, we create we have one file which we think is important for this analysis, and then we simply create a property which has this file as a content. And now this file here, it doesn't live within the SQL database of LinkAhead, but it continues to live on the local file system of the computer where it was stored. Is this more or less what you were asking?
Yeah, and in that direction. So there's even one more file behind this file. That is already an analysis of a raw file, how to say. So it's saying it's a spectrum, so you first have to have the real time domain signal which you record, and then this is already an analysis of the raw record file.
Yes. Yes, but yes. So, but in your actual example, of course, it would be also possible to store the raw record file as a file reference here as well.
Yes, thanks. Yeah.
Let's download the data to. Do we have a command line way to execute and download the data? Yes. Yes. So if I want to have this query here, let's go back to the query and do it, and then export. And here we see, okay, we have this one. If I execute this query in a Python context, I get a CaosDB object which I can with another single line convert to a pandas data frame, and then this data frame is okay. And so basically the Python command, at least this Python command doesn't download any data, but of course, if you want, you can, if you have a file record inside LinkAhead, you can either download the binary content of this file, or, which in many cases makes more sense, you can also download the location of the file, which you can then use locally without needing to download it again via LinkAhead. And we have a command line way to execute queries and download the data. Yes, you have. And with integration of a record type for each
Let's read it so we have it in recording properly. I would say.
Okay. The question was, I imagine the creation of a record type for each analysis, experiment, simulation you perform can be rather lengthy and tiring. Can you share your experiences with this? Yes, if you the amount of effort you have to put into this, of course, depends on the level of detail you want to have in the end. Of course, the ideal way would be to really create a new record type for each kind of experiment you have. But of course, with LinkAhead, it's possible to start easy and do this detail later on. Thomas had this crawler slide, and the crawler, and for the crawler, there are some standard plugins which allow you to simply use your existing file structure and then create records in LinkAhead for each folder it finds. So for example, you can say, okay, I put all my experiments into one folder named experiments, and then I create one subfolder with the day for each experiment, and then I simply want one experiment record for each of these days, and this is exactly possible with the standard plugins which come with a crawler. So and then if at a later point in time you decide that this is not enough detail and you want it in more detailed way, then it's no problem to modify the data types within LinkAhead and say, okay, I now want a different type, and then from this time on I will start to use this more detailed type, and then because the data model in LinkAhead is so flexible, you can use the old and the new data side by side without the need to migrate the old or existing data. If there are no more questions at the moment, I think it makes sense to show this in a small example here also on the demo server. So if you remember, we had this tensile analysis record types. And here in this record type for the tensor analysis, we have a property called color, and this color typically is only a text, so it can be a gray or orange or blue or whatever, and this may be fine for you, but after some time you may decide, okay, I want to invest in my lab, and now I have a fancy new device, and this device doesn't only give me a color, this device gives me a whole color measurement. And this color measurement gives me a wavelength, which is much more, much more precise than only some text. Okay, what if I want to implement this change to the data model in LinkAhead? Well, we first, of course, need a new property for the wavelength. So we say, okay, we have a new property called this wavelength. Wavelength is a number and has a unit which typically is nanometer. Yes, nanometers. Okay. And then we say, okay, we want to have a new record type for this measurement of the wavelength, and we say call this a color measurement. And this color measurement shall have a wavelength as a property. Let's save this. And now I say, okay, we have this tensor analysis which we had before already, and we want to change this color into a color measurement. So we say, okay, let's edit this record type. We say this color, we can throw it away. We say, okay, we want to have a color measurement instead. And we save it. And if we now create a new record, which of course can also be done on the command line with Python and so. But for you to show, I will just do it here online on the website. We can call this new and analysis. Use some arbitrary references here, which I think which are not important at the moment. To tensor string of 120 Pascal, and we say, okay, we want a color measurement. Oh, I forgot to create one. So let's save this for the moment now, and let's create a color measurement. So we want to do color measurement record. Say the color blue. Blue is something like 400 something, 460 or so. The question from a way which may have been used earlier, wouldn't that delete data? In other systems, it might delete data, I don't know, but here it doesn't. With something which we'll see in a few seconds. So we have a new record of 460 nanometers, and this is now something which we can use here. And we say, okay, this new tensor analysis shall have a color measurement with the color blue with a wavelength 460. And of course, it's simple to see this one record here, which has this reference now. But I think it makes sense to look for the existing, for the old one, for the old records, which used to have a color, which was just the text. So we want to see find record and the analysis. And we see happily side by side. We see here the two old measurements. There are two old tensor analysis records, which one has a color white, one has a color gray, and this one doesn't have a color, but it has a color measurement, which is linked here, and which is the color blue, which has a wavelength 460. Now, of course, if you want to say, okay, we don't want this one, but we want, for example, find tensor analysis with color measurement with wavelength smaller than 0.00046 meters, and I think there are 3 zeros missing. And I found this one. And I didn't find other ones, of course. And even of course, if I look for larger than this, the others won't show up either. Yes, there's one more question. Sorry, I may have missed it. Is it possible to automatically convert old properties to the new one? For example, red equals to 700 nanometers. This is, of course, possible if you write a small script which does this. It's not possible right away, and we leave out this possibility on purpose because it may be simple to think about this in the case of colors and say, okay, we have green is this wavelength and red is another wavelength, but actually it's not always that easy, and it isn't even that easy with our examples because, for example, if you look here, it's really hard to say, okay, which wavelength would you give the color white or the color gray? And this actually is a good example, I think, for the problems you face if you have a system which would force you to migrate your old data. If you use LinkAhead, it's all up to you to decide if you want to do this kind of conversion, and if you want to write a small script which does this conversion. But of course, if you decide not to, it's totally fine. So if you wanted to do this kind of conversion, you could write a small Python script of I don't know, 10 lines of code or so, and you would be fine with this. Yes. Now, if you yes.
I have a question. So when you're describing this data crawler model, how would you pull out something like this wavelength using that? Because you're saying, creating subfolders is the typical use case to create, say, a metadata file along with the experiment that then gets parsed by the data crawler as you add things to a folder. Is that the? Go ahead. Sorry. Oh, I said just go ahead.
Okay.
Yeah.
Yes. So, for example, if we now say, okay, we have some script and we want to do some analysis on the color. Of course, in this case, it's up to you to handle this kind of ambiguity. So, as an example, you can say select color, and I also want the color measurement from record tensor analysis. So if you now do this, or actually I think I would even want to say color measurement dot wavelength. So for example, if you want to do some analysis later on in your script, in that case you have to decide how to handle this ambiguity, and say okay, it may be that I only want to use those records which have a wavelength. Maybe that I want to modify these and say okay for these I will for these I will handle them differently. If you however decide to modify these and say okay, I want to change this. So for example, for this one I also delete the color. I add the color measurement instead, and I use this one. Save. Even if you do this, fortunately you have the way to find out that this record here is not in the state in which it was originally, because with LinkAhead you have tight version control. So I can say okay, I have a previous version which was this one. But I see that today at 1646, it was changed by the admin, and this new version now has different properties. I think this is it so far for the live demo. But of course, if you have more questions, yes. If you have more questions, please go. If there are no more questions, I think we can continue with a short presentation. Thank you about that.
All right, then I will start sharing.
So I can also do it. I have it open as well, presentation. Yeah.
There's another question. If I have a script, what do I do in the analysis in practice?
Sounds quite general, this question. What do I do in the analysis? Can you elaborate on this, Balthasar? Okay, later. Okay, so we have had the live demo. As I said, as I mentioned, in the crawler is written in Python, but we also have client for Julia, C++, Octave, whatever. And yes, as a summary, LinkAhead, as Thomas mentioned, is fully open source software. It's licensed under GPL. So whatever we do with the software, it will always be free. Has these powerful search options. It's really easy to extend or modify it with the use of scripts use of scripts. The crawler makes it easy to integrate into existing workflows. So if you have this crawler and if you simply have it crawl over your files every hour or day or so, it's really easy to keep your workflows unchanged and still profit from professional data management. And it really allows to semantically connect the data you have. So that in the end, you do not only have a big storage of files and you have one folder of experimental data, one folder of analysis, one folder with the publications and so on, but you really can connect these to each other. It's really easy to find out, for example, for a publication, to say, okay, I have this plot here, and I want to know where the data is which was used to create this plot, and I want to know which scripts were used to actually create this plot. Yes. So thank you for your interest. And again, we want to mention the next two online events, which are Thursday next week and in a fortnight. And the first one will be about how to integrate LinkAhead with one example of an electronic lab notebook, EDAP-FTV in this case, and the second and the online workshop after this will have some practical insight into how you can use LinkAhead to use it with your data. And then at the bottom here we have some useful links. So the demo which I just showed you, you can access it at demo.indiscale.com. You can play around with it. You can access it with your Python script, and you don't need to be afraid to damage anything because the demo server is reset every day. There's an extensive documentation at docs.indiscale.com, and you can, of course, download the source code at gitlab.com. Okay, I think this is it.
Okay, I will stop the recording for now in case anyone wants to say something.